All right, so now we're going to see how all this complex number stuff relates to trigonometry. So let me get my pen on, right? And so how this does this is how we decide to graph complex numbers. All right, and what we're used to is we're used to the rectangular coordinate system where we have an x-axis and a y-axis, and that's been doing fine. But for the complex number system, we're going to replace the x. It becomes the real axis, and y becomes the imaginary axis. So when I'm dealing with an ordered pair, let's say like 5 plus 2i, right? That means that my x-coordinate, right, in rectangular coordinates, my x-coordinate is 5, and my y-coordinate is 2. So when I go plot this point in the complex plane, right, this point would look like the following. And it's got some radius length to it, right, some distance, what we called magnitude earlier, right? And it's got an angle theta to basically give us direction. Of course, like we saw in the last thing, right, the x value is that r times the cosine of that angle, and the y value is the r times the sine of that angle value. All right, so it kind of mimics what we saw for vectors, but we're not dealing with a vector. What we're doing is we're trying to create a system where we go from an xy, right? This is rectangular coordinates, to a system that we call polar that is in terms of r theta. So r tells us how far we are from the origin, and theta tells me how far we're going to rotate. And that'd be another way. So rather than calling this point the point x comma y, right, that's the rectangular version. In the polar version, we say that that same point is r theta. All right, so it tells you how far you are from the origin and how far you rotated. And there's basically the tie-in. So in rectangular form, right, we're going to go from a plus bi, the way I introduced them in a previous video, to now x plus yi, right? And that creates the ordered pair xy that I can see on my graph. And now what we're going to do is we're going to convert this to polar form, where we know that x is r cosine of theta, and we know that y is r the sine of theta, right, I. And in this case, right, in polar form, this tells us, the r tells us how far we are from the origin, and theta tells us how far we rotated. And so we basically can describe the same point, right, in a rectangular form or in a polar form, which, as we see, involves our trigonometry, our sines and our cosines. All right, and we can also further say that the r, right, satisfies what we've always known, right? It's x squared plus y squared, and that the tangent of theta, right, is my y value over my x value. So there basically is your polar form of our trig function. So we can go from a rectangular situation in the complex plane to a polar form in our complex plane. And this is going to have some pretty big ramifications for you in future math courses when you start graphing things in polar coordinates, or even solving differential equations, which we'll do. I'll just kind of give you a baseline of what that is. But it all basically comes back to this and this guy, de Moivre, right? But that's more math coming soon. I'm just going to give you the basics, rectangular to polar. So now that we've been introduced to that, let's basically do some examples, right? So I have the rectangular coordinate. This would be 1, 1 in rectangular coordinates, right? And if I graph this, I'm basically talking about the complex number, right? 1 and 1. We've seen this before, right? So I know that in this case, right, my r squared is 1 squared plus 1 squared. So r squared is 2. R is the square root of 2. And since my sides match, we know that to be 45. So going from my rectangular form to my polar form, right, I can basically say that 1 plus I is the square root of 2 times the cosine of 45 degrees, right, plus the square root of 2, the sine of 45 degrees. Okay, oops, and that's not the vector, it's the I. All right, and then last but not least, so we have our polar form is 1, our rectangular form is 1, 1, and then I probably should let you guys know that when we are working in polar form, right, we actually do use radians. All right, so that would be the polar form, that would be the rectangular form, right? And here's the complex number written in rectangular form, and here's that complex number written in polar form. This would just be pi over 4 and pi over 4 respectively. Okay, or you just keep writing things in degrees, but I want to get you, we usually go radian. All right, so that's it. So the next one, again, here's, we're talking about the ordered pair, -1 comma square root of 3, right? So that's rectangular. So if I drew a picture of this, right, I'm -1 in the x direction, and then the square root of 3 is not quite 1, it's not quite 2, so it's somewhere in between. So there's -1 square roots of 3, right? And there's basically my r. Again, we have seen this triangle before. We know that it has a 60-degree reference. So the angle I have is 120 degrees, or in radian mode, we know that to be 2 pi over 3. And the radius is 2. And again, that can be verified. The square root of 3 squared plus 1 squared equals r squared. So r squared basically equals 4. So r equals 2. So I could basically go from rectangular description of my polar coordinates to my polar form, right? Which would be 2 cosine of 2 pi over 3, right? Plus 2 the sine of 2 pi over 3 in the I direction. Or in terms of coordinates, right, the rectangular coordinate would be -1 square root of 3, and the polar would be 2 pi over 3. So I can tell you that we're going 2 units away from the origin, right, and we're rotating 2 pi over 3. That location there in polar form would be -1 square roots of 3 in rectangular form, right, and so forth and so on. And the next one, again, the rectangular form, we're actually in quad number 3, right? So we're our x coordinate is about negative square roots of 3. My y coordinate is -1. So when I draw my representative right triangle, right, my theta in this case is there, but we know we have a 30-degree reference in there. So my theta for this situation, using some previous knowledge, right, my theta is equal to 210 degrees, which I think in radian mode is 7 pi over 6. And my radius, again, is 2 for the right triangle situation that I have. So in rectangular coordinates, we've got the ordered pair, -3, negative square root of 3, -1, right? Describing the complex number, dang it. Describing the complex number, negative square roots of 3 minus I. In polar form, I have the radius of 2 and a rotation of 7 pi over 6, right? So there's my r theta versus my x and my y. And we write this as 2 the cosine of 7 pi over 6, right? And then plus 2 the sine of 7 pi over 6. So that's basically how we do that, okay? And so for the next one, when we draw a picture, again, ordered pairwise, we're talking about the ordered pair 2 square roots of 3. So when I draw a picture of this situation, right, what we end up having is we're 2 in the x direction and -3 in the y direction, right? So there's basically, right, my angle theta, right? And unfortunately, right, we can find our r pretty easily, right? R squared is 2 squared -3 squared. So r squared, what is that, 13? So r is the square root of 13. So my polar form, right, is the square root of 13. My angle though, right, what I need to do is find out what this reference angle is, and that's going to come from following the definition, right? We know that tangent, right, of the angle of rotation, right, is my y over x value, which in this case is my -3/2. So theta is the inverse tangent of -√3/2. So we're expecting something in quad number 4, but we know from previous work that when I actually perform this on my calculator, right, what we end up with, let me punch it. We actually end up with -56.3099 degrees. So we basically, remember, because of the domain restriction, we're rotating in a negative direction there. So that's why it's giving me that value. So to find this one, right, I basically just take 360 degrees and subtract that value. And I think when we do that, our theta becomes 303.6901 degrees. So that would basically be our polar coordinate. Okay, and I'm running out of room here, but basically the polar form, right, would be the square root of 13, the cosine of that angle I just found, plus the square root of 13, the sine of that angle I just found. And I'm going to go ahead and keep it in degree mode because it's, we're not used to seeing radians in decimal form, right? So that's why I'm going to keep it there. So there's basically it, all right? So we now have, right, the moral of the story, right, is that we can think in terms of rectangular coordinates, x and y, to describe an ordered pair, or we can think in terms of polar coordinates, r theta. So how far away are you from the origin, and how far did you rotate, to describe the same, what's your x location and your y location. Complex number wise, right, we can write our complex number in terms of x plus yi to r cosine theta plus r sine theta. All right, so there's your introduction. There's so much more math you guys are going to do with this in your future careers, but there's basically the baseline. All righty, thank you for your time, and we're going to go look at an application to wrap things up.